Hello everybody and welcome back to Good Sauce Tech. My name is Vlad and today we are starting our C++ tutorial. This is episode 1. So, we're going to be doing C++ because it is usually the language that you will study very early in your programming career, if you want to call it that. Usually if you study computer science in high school at all, you will probably see C++. You'll also probably see it very early in your university program if you do computer science in university. At least it was the first language we studied. So yeah, without further ado, let's get into it. So this thing that you see right here, this is our IDE. It is the software that we will be programming in. You can do this in Notepad, or any text editor really. But I'd recommend getting an IDE. This is a Visual Studio Community. It's made by Microsoft, and it's completely free. So if you want to get Visual Studio, you just want to go to the link in the description, and it will take you to this page on the Microsoft website. You can download it, which will then give you the an installer file. You can use that to install the Visual Studio installer, which is a bit confusing, right? But then you can open the installer and it will take you to something like this at some point. And then because we want to code in C++, you want to get the desktop development with C++, maybe also get the Linux development with C++. If you want to do games, you can do this as well. Mobile development. You can always open the installer back and then get to this page and add or remove things, so you don't have to worry about it. You can just, go to modify. And then there you go. So now that we have that covered, let's jump into the actual coding. So the thing with programming is that it's actually very simple, right? It's just a conversation between you and the computer. You're just telling it, you're explaining to it what to do. Because computer is very smart, right? Except when they have to do something that they haven't done before, then they're extremely dumb. So you have to explain like very basic, very step by step. So let's start with the first thing that you ever do. For now you can ignore everything that is here. The green text is called comments. The computer ignores comments. We'll talk about that a bit later. You can also ignore this up here for now. Just know it has to be there for now. If you want this file right here so you can follow along, you can get it at the link in the description. It will be a paste bin link, so you can download it, copy it, whatever, right? So, first up, let's print something to the console, right? I'm gonna get on a new line, and if you want to print something, there's several ways to do it. The most usual way to do it at first is you want to say cout, and then you do these signs right here, and then you tell it what you want to print. You want to print hello world, right? And then you have to end your line with a semicolon. This tells the computer, alright, I want you to, well, it's obviously, right? Console out, right? This is a stream operator, don't worry about it, just put that there, right? And then what do we want it to output to the console? We want it to output this string, right? And if we run it, you run it by clicking this here or pressing F5 on your keyboard. You will see that it compiles and then it runs. And then it says hello world right up here. And then this is just telling you that it exited and everything, right? Okay, so that's pretty simple. Then we can also print text with a new line, because usually when you print more than once, you want every single time that you print, you want it to show up on a separate line, right? Because if I just print right now, I can say hello again, right? And end my line with a semicolon, that's important. And then if I save it and run it, you'll see it doesn't actually go on a new line. It goes on the same line as the previous statement. That's useful sometimes, but in this case, we want it to go on a new line. So the way you do that is you can put this in there. This is a new line character, a \n. Don't have to worry about why it works like that. It just works like that. There are some characters that you can put in, and they will do some things, special things. You can do that, or you can also print an end line that has the exact same effect. For optimization, this is more efficient, but you don't really have to worry about it, right? Now if we print again like this, you'll see There you go. Hello world, hello again. Right, that's very basic, that's the most basic thing, but now that we've got that covered, we can jump into something slightly more exciting, which is that you don't really have to print text, right? You can do cout, console out, right? And then you can say 2 plus 3 equals, and then you can say cout 2 plus 3. And this, if we run it, we'll say 2 plus 3 equals 5. Now there's a few things to be known here. First up, we didn't use the new line character because we wanted it to show up on the same line. Second, we put this text between quotes. Everything that you put between quotes is considered a string, and strings are printed literally. So the exact thing that you have between your quotes is printed, nothing is analyzed, calculated, or anything, right? So 2 plus 3 equals gets just printed straight out like that. This is not between quotes, this is an expression. So the computer will look at this and say, okay, I have a whole number plus another whole number, it will add them together, and it will get a 5. And then the result of this thing gets printed. So you get 2 plus 3 equals 5. Let's also print a new line so it doesn't get messy in the future. And now you see how this is kind of messy. We're doing all of this just to print one line of text, right? You can actually do it much cleaner by just putting it all on one line. You can say cout and then do the stream operator, and then you can say 4 minus 5 equals, and then you can do the stream operator again, and then you can add more things, 4 minus 5. And then you can do the stream operator again and add more things. And if we save it and run it, you will see that this works just fine. There you go, 4 minus 5 is minus 1. Alright, so that was the very basics of printing. There's a lot of things you can do, but this is more than enough to get you started. So now let's talk about variables. It's right in the name, it's something that can change its value, it varies, right? Basically, you can store things, sometimes you want to store information, and you can store it in a variable, and then you can use it later when you need it again. That might not make sense right now, so let me show you what it actually means. So, let's say we wanted to store a number, right? Store a whole number. We could say it's an int, that comes from the word integer, right? We can call it anything as long as it respects the rules, and I'll tell you the rules in just a second. So let's call it my number. I can spell it, right? And then we can say my number is equal to 5, right? So now the computer knows that whenever it sees the word my number, it actually means 5. So if I say cout my number, and then an end line, you'll see that it actually prints a 5, because it knows that my number is 5. Because this is a variable, it means I can change it, right? So now I can say my number is 7. And then if I copy this line over here, and paste it down below again, you'll see that it will say 5, and then it changes, right? Here it's 5, it prints it, it changes to 7, it prints it again. Now it's a 7. Very simple. Okay, so we've got that. Now you will notice that I did put an int before it, over here, and I didn't over here. This is called a variable declaration. Before you can use a variable, you have to tell your computer what it is, at least in C. There's other languages that do this by themselves, but in C you have to tell it that it is an integer, right? Over here, it already knows that my number is an integer, so I don't have to tell it again. You also don't have to give it a value at first. You can say int test, and that will work. That just won't have a value. It will just be some random number, right? And then you can later just say test is 3, and then you can print test, pardon me, print test, and it says 3, as you can see right here. Alright, so this is an integer. That's a whole number, right? So it doesn't have any decimal places, but it can go into negatives, of course. So you can store like minus 345. If you don't want to have it go into the negatives, you can call it an unsigned integer, right? That's the thing that happens. So that's it can only take positive numbers. You can also have bigger or smaller numbers, right? Because integer has a certain capacity, right? It can only store 32 bits. If you want more than that, there is actually something for that. You can call it a long, and that has more. That has 64 bits, if I'm not mistaken. So that can store very big numbers, right? I'll actually put the limits on screen for you as we're talking about them, but you know, just know you usually won't run out of numbers, but you know, it's useful to know that. If you don't need a very large number, there's also like smaller versions. You can have a short, which is just shorter than integer. It's half the size of an integer. You can store half the numbers, right? Right, doesn't matter. These aren't actually any limits, right? That's just random numbers. All right, so all of these are whole numbers. They're integers, right? If you want to store decimal places, then you can go down here and I'll show you that you can store them like this in a float. So why is it called a float? It's called a float because the point, the actual decimal point, can move around basically. So it's called a floating point number. That's where the float comes from. We can again call it whatever we want. And then we can give it a value like 13.4. C automatically assumes that anything that has a point in it is a real number. We'll get to why that is important in the next video, I think. You can definitely also say, oh, don't forget to add a semicolon at the end. Yeah. You can also say float, my float 2. Well, let's spell it again. You can say that's 5, right? And because we told it it's a float, it will consider it to be, you can see right there in the suggestion, it considered it a 5.0, right? If you want bigger numbers, bigger real numbers, again, there's obviously an option. It's called double, and that works as well. Again, don't worry for now about number size. Int should be plenty and double should be plenty for whatever you need for your whole numbers and your real numbers. Again, double works the exact same as float, it can just store bigger and more precise numbers. We'll get into what precision is at a later point. Logical variables are something else that you are going to run into. So sometimes in programming you want to store a true or a false, right? You want to remember if some test that you did was true or it was false. Now, of course, you can say like int result is 13, right? And then you can know, all right, if it's 13, then it means that thing was true, and then if it's not 13, it means that thing was wrong. But that's a clunky way to do it. It's not very useful, and it's easy to get confused. So C++ has something called booleans, and most programming languages do, which is declared like this, bool, and it is either true or it is false. Very simple. It's true or it's false. We'll copy this over just so we have the true as well. Call it my bool2. There you go. So, what you saw before over here was a string. Now, of course, you can't store a character as a whole number, as a boolean. Characters are technically stored as whole numbers, but they're actually stored like this. So you can say a char, that stands for character, right? It's short for it. And then you can add a C. And that's a character, right? You can print it, you can do lots of things with it, but you have to store it between single quotes, right? Between apostrophes, basically. If you want more than one character, then you want a string of characters, right? To make your text, right? If you'll say string, my string, and this goes between double quotes, is welcome back, right? And you can even add your new line to it and whatever you want, right? What else? Constants, yes. So these are all variables, right? All of these you can declare, you can change whenever you want, you can modify their values, add things to them, remove things from them. Constants are for when you want to declare a thing once and you want it to always have that value throughout your program, right? So any of these can be constant, right? Any of these types. It's just constant just tells your computer don't ever change this. So let's say we have like a number that we don't want to change. Say like float interest rate, right? If you're programming some banking app, and you can have it be 0.05, right? So it's a 5% interest rate, right? But you don't want anyone to be able to change this in your program because this may be very central to the way your program works. So we'll just tell it it's a constant, right? Now it's const float. And that just works the same way. You can still print it, you can do math with it, as long as you don't try to change it. If you try to change it, if we try to say interest rate is 7, you'll actually notice that it's complaining, right? And if we hover over this line, it will say expression must be a modifiable value, which this interest rate is not a modifiable value because we told the computer it's a constant. There you go. If you try to run it like this, it will complain, it will not compile, and it will ask you, do you want to run the last successful build? We'll say no for now. Again, any of these, just put const before them and they become constant. Right, so I told you you can name them anything. It's very nearly true. There are a few rules. So, your variable names cannot start with a number, right? You can't call it 1, 2, 3 times. That's not a valid name. And they have to start, they also cannot start with like an exclamation mark or something like that. They cannot be reserved names, such as float or const, or like later we'll see if. You can't call your variable if, right? But as long as that's met, you can have numbers in the name, like you see over here. They just cannot be the first character. So that's it for variables. That's the boring bit of programming, right? Now let's get into it and do something a bit more exciting, right? Let's read something from the console. You've seen how we do writing up top over here. So when we want to do reading, it's very, very similar. You say cin, C for console and in for, input. You do the opposite stream operator, right? Goes to the right. And then you tell it a variable where it can put the result that it reads. So say we want to store somebody's age, right, in years. Int, we'll call it my age, and we won't even give it a value, right? And then we'll say, all right, read my age. And this might not make sense, but we'll show you right now. So if I run the debugger, right, it will open, and then you'll notice it doesn't print the thing that it does when it ends, right? Because right now it's waiting for my input. You'll see this thing is blinking right here. So I can say I'm 20 and hit enter, and then it will read that, put it in the variable, and then it can complete. But right now we just read something and never did anything with it. So what you would want to do is actually use this value. So we can use that value by saying, we can print the response, right? We can say, yeah, you are, and then right here we can put that value, right? We say my age, years old. So that will print you are space, and then it will print my age, and then it will print years old and the new line. If we run it, you'll see it asks us for our age. I'll say I'm 20, and it says you are 20 years old. Okay, that's cool. We can also do something like addition. But for addition, you want to read two things, right, that you want to add together. So let's do that over here. Let's read multiple things on the same line. So you can say int A and B, right? Very simple. Just the way you can read multiple things on one line, you can declare multiple things on one line. So now the computer knows that A and B will be whole numbers. We can now read A and B, just like this. Put the stream operator, first thing you want to read, stream operator, next thing you want to read. Computer understands this, and you have to give it the numbers in this order. And then we can print, we can do this, we can say A, then we can print a plus, and we can print B, then we can print an equal sign, and then we can print A plus B. So what will this do? This will print, let's say we give it 2 plus 3. We'll print 2, because that's the value of A that it read from the console. We'll print a plus. Then we'll print B, which is 3, because that's the value it read from the console and it put it in B. And then we'll print A plus B. If we run it, of course it will ask us for our age again. Let's say we're 56, you're 56 years old, and then we'll ask us for two numbers, right? We'll say 2 and 3. And we'll say 2 plus 3 is 5. Of course, this works for any number. If we run it again, some random age, and then we'll say 9 and 446, and then we'll say 9 plus 46 is 55. Okay, so that's it for printing. Printing works, that's it for reading. Reading works like printing. Printing works like reading. Obviously, they're just like the opposite stream operator and a slightly different call over here. So, some other very miscellaneous basics that don't fit into anything else over here, but that you have to know at the start is, first of all, comments. You've seen plenty of comments, all of the green text over here. That is text in the file that the computer will just completely ignore, doesn't care, doesn't run it. It's just for programmers to be able to figure out what a program does. That's very useful if you're reading someone else's code. It's also very useful if you're trying to read some of your own old code, because you will totally forget what it means. So an example is what you see over here. So if you put 2 slashes at the start of a line, it becomes green. Well, in Visual Studio it does. And then you can type absolutely anything over here, computer will completely ignore it, right? Let's say if we were to put 2 slashes here, it will not run that line. So if you run it again, and we say we're 20 years old, and then we give it some numbers, right? You see it took the numbers, but then it didn't print anything because that line is not being run, it's a comment. These are one-line comments, obviously with the 2 slashes. You can put however many slashes as long as it's at least 2. Another thing that you can do if you want a big comment, like if you want to write several lines, you can do a multi-line comment by doing a slash and an asterisk, and then Visual Studio will autocomplete it, but you would put the asterisk and the slash as well. and then anything that is between these two things is a comment. Of course, Visual Studio adds these things, you do not need them, right? It will work just as well, but the thing is, if you have a single line comment and you try to do this, text over here actually gets run. So if you try to run this, it will complain, it will say, well, you can't do that. And you can see your errors over here. You can say identifier ASD is undefined. Of course it is. So that's it for comments. Comments are very simple. They're just a useful tool for reading your own code. The last thing that we'll talk about are semicolons and expressions. What you need to know about this is that every line in C ends with a semicolon. There are very, very few exceptions, and we'll get to those later, but for now, everything that you've seen over here needs to be ended with a semicolon. The reason for that is that is how the computer knows that this expression is over, and it needs to look at the next thing as a brand new expression. You don't have to put everything on a new line. You can do it like this. You can say int C is 5, put a semicolon, then you can say C is C plus 4. Very simple. Now C is going to be 9. And then you can say C out C, right? And that will, if we run it and get past the age thing and the addition thing, it'll say 9, the 9 over here, right? Because we didn't put an end line over here. Let's add an end line. Right? This is hard to read, so it's very much encouraged to put every single expression on a new line. But they all have to end with semicolons. If we don't end it with a semicolon, then the computer gets very confused and it goes, oh, expected a semicolon, right? Expected it over here. So that is about it for now. Please stay tuned for the continuation of this. Let me know if you have any questions about this in the comments, anything we discussed. There, you can also hop on the Discord server if you have any questions and you want to discuss anything over there. This final file, if you want to look at it some more, mess with it, change things, see what breaks, see what doesn't break, this file will also be in a link in the description. It will be a link to Pastebin where you can download the file, you can copy the text, whatever you want to do. This was, again, the boring part of computer science and of programming. We'll get to the actual interesting bits in a bit. We'll make some games, some very simple games, but we'll make some games. So stay tuned for that. So I really do hope you enjoyed this video, and if you want to see more, you can click on the right to watch my latest video or on the left to watch a random video. Or just click the round channel icon in the middle to subscribe. And as always, this has been Vlad from Good Sauce Tech, and I'll catch you in the next one. Take care, bye bye.